we're going to learn about something that can save you hours and hours upon work in the Unity game engine. And this is called scriptable objects. I'm going to show you what they are, how to make one, how to use them, when you'd want to use them, and I'm going to compare them to other methods that don't use them so you can get a better idea of how they work and why you might want to switch over to using them. Scriptable objects can make it easier to prototype. It can organize your code to make it easier to understand and change for both the coders and designers. And this results in quicker iteration times on both sides, especially for designers who might not have entirety of knowledge on the code base and may just want to change a couple of values around. And speaking of game design, this video is sponsored by Machinations. Machinations is the game balancing platform, which you can map your entire game and then run simulations to balance the parameters, which is great for fast game design iteration. How do you know if you need Machinations? Well, you're swamped with spreadsheets, text documents, diagramming tools, and whiteboards, so you know that balancing is more than a circus act. It's the cornerstone of great player experiences, and you want to make sure to get it right. You believe that guesswork is for the fortune tellers. Game designers should rely on proven science. You want a reliable way of predicting player actions even after thousands of iterations. Machinations will help you get laser-focused clarity, rapid prototyping without writing any code to help you balance your player's experience. And this can save you up to 90% in balancing and iteration time, which is huge. You can start from hundreds of ready-built templates, or you can quickly create your own by using the prefab library items. You can easily bring your whole team in and work with them on the same diagram by using the live collaborative editing feature similar to Google Docs, so you can make edits in real time. They have extensive and awesome documentation, YouTube tutorials, and they host regular webinars, so picking it up will be a breeze. There's a plan that's free forever that gets you really far. You can try it out by using my link in the description and start designing your own Machinations. So, scriptable objects. Everyone's talking about them. What are they? Well, a scriptable object is just a fancy way to say that it is a container of data. So in its primary use, they are meant to contain data that you might need to play your game. For example, let's say you have an enemy and your enemy has different stats, such as health, speed, and a type of attack. Well, instead of creating a mono behavior to store this data and attaching it to your enemy, you can make a scriptable object instead to store the data. Now, the main difference between these two approaches is that a scriptable object is an asset. So this is an asset within your assets folder, and you cannot initialize a scriptable object in your scene. So this is a project level asset. This also means that this does not depend on the scene in any way. So it is scene independent. Any game object from any scene can access this data. You do not need to get a reference to another object in the scene. Now with a mono behavior, usually what you would do is that you would have this zombie, you would make a prefab out of it, and if you want to change the stats, you would make another prefab variant out of it with the new stats. But you can see that this can quickly add up to having a bunch of different kind of prefabs. And what happens if you change something in one prefab that you need to now change in all the other prefabs? And that's because the zombie has a direct dependency to those stats. So when you have dependencies, when you change something, it can cause something else to break, or you might need to change other objects or scripts to account for the new changes. Scriptable objects makes our life easier because we extract that stats information from the zombie and we put it in this data container within our project level that we can easily duplicate and have different scriptable objects for our different enemies with different stats. So there's a lot more to scriptable objects, but right now I just want to show you how to make a scriptable object so it's easier to follow along. So in your assets folder or wherever you have your scripts, you can right click and create a new C# script, and you can call it whatever you want. In this case, I want to make an enemy scriptable object, and usually you have the word scriptable object after what you want to make a scriptable object of. So for example, I can just call this enemy scriptable object. And I actually already have a script like this on the scene, so I'm just going to add a 2 to it so it doesn't get confused. So once you have this script, you can delete everything for the most part, even these 2 using statements from system namespace. Just make sure you have using Unity engine. And all we have to do is, instead of extending from mono behavior, we can now extend from scriptable object. And ta-da, you have your scriptable object. But we actually have to add some data fields into it. So let's say our enemy has different properties such as health and speed. So you can just declare as you would any other script, public int health, and you can set it to a value. And you can also put speed, so you can do public float speed. Maybe set that to 5. You can also make these private with a serialized field, as so, but I'm going to want to access these from other methods, so I'll just leave them public for now. Or you can make a getter and setter as well. So this is like our blueprint, our recipe. And then what we can do is in the assets folder, we can create an asset out of this script that contains our data. Unfortunately, out of the box, this is not supported directly. We have to make this accessible from the assets folder. So to do that, we can add these two brackets here and type create asset menu, parentheses. Then we can add a file name, which is the default file name that will be given to our created asset. In this case, I'll just call it enemy scriptable object. And you can also add in a menu name. So you know when you right click in the assets folder, a bunch of stuff pops out and it's sometimes hard to see what you want to select. So this will make it easy for us. So we can put it under a folder called scriptable objects dash, and then we can call it something specific. So in this case, I'm just going to call it enemy2. You can just call it enemy1 in your case. All right, so if we go back to the editor now and we right click create, you see that now there's a new option here called scriptable objects, and this will have all of our scriptable objects that we made if we put it under this menu item. So now we can create an enemy2 scriptable object and we can name it anything we want. In this case, if we have an enemy of a goblin type, we can just name it goblin enemy. And you can see now that this is an asset in our project with health and speed, and we can change it in the inspector. So it is important to note, since this is an asset and is not bound to our scene, that means that when we change the values, either through here or through code, while the game is running, or even while the game isn't running, then those values will be saved. Unlike normally, when you press play mode and you change a value in a component, for example, if you change this slope limit of the character controller while in play mode and you exit play mode, it will not save that value. With scriptable objects, it does save that value, so it makes it really nice for prototyping. And if for some reason you didn't want it to save the values, you can easily write a helper function to instantiate a new scriptable object through code and change those values at runtime, and that wouldn't affect the original scriptable object, which I'll show you how to instantiate them through code as well. Alrighty, so now I want to show you a more concrete example using this space here. And I'm going to open up the script that I already have created. So the only difference here is that we are also taking in another parameter called enemy attack scriptable object. So let's say you have an enemy, and let's say your enemy attacks the player. Now, what if your different types of enemies have different kind of attacks? Well, what you can do is input scriptable objects within other scriptable objects. So in this case, we're inputting this enemy attack scriptable object, which if we go to, it's just another scriptable object with other parameters such as attack damage, attack range, and attack sound, which is a reference to an audio clip that we can play in our script whenever the zombie attacks. So this makes it super easy to swap in different attack types when we want to test on either different enemies, or we want to test the same enemy, test different attacks. And I just want to highlight that another benefit of using the scriptable object is that it can save you memory and performance. For example, in this scriptable object, we are referencing an attack sound. So let's say we have a bunch of enemies on the scene, and if we were using mono behaviors, we'd need to create an instance of an audio clip every time we instantiate a new prefab. And so now you have a bunch of instances of something for each prefab, when in reality, if you can just reference the existing instance within the project, then you wouldn't need all these created instances. Just like in this case, we have a reference to an attack sound, even the attack damage and attack range, we only have one instance of these variables instead of having an instance per prefab of each enemy. So you can see if we have 1,000 enemies, we need 1,000 instances of the enemy prefab to be instantiated, and each of those instances would need to put these variables in memory. However, since the scriptable object lives in the assets folder, and there's only one instance of it which you cannot instantiate, now this is only in memory once instead of 1,000 times. Alright, so back to the editor, I just want to show you a more concrete example using these enemy scripts that I've made. So in this case, I have a zombie with an enemy controller, which the enemy controller, basically, all we're doing is getting a reference to the animator, and I'm just storing the different animations that it has so I can access it easily, like the IDs of each animations. Then what I'm doing here on start is that I have an audio source attached to this zombie. So what we're doing here is we're referencing this enemy scriptable object, which if we scroll up, all we have to do is type private or public enemy scriptable object, which is the name of the script that we made, and our variable name, just like any other variable. So you can do enemy scriptable object dot, and then I'm going to reference the enemy attack type, which is the other scriptable object that I made that has the type of attack, dot, and then we have these public parameters that we can access. And in this case, it's called attack sound. So basically what this script is doing, it's saying that while the enemy is not in range of the player for its attack, then follow the player. And once it is in range, then attack and wait a couple seconds until starting to follow the player again until it gets in range again. And for the range, we use the property from the scriptable object, enemy scriptable object dot enemy attack type dot attack range. And this is just a simple example to show you how to reference a scriptable object within the scene. And so if you add the enemy controller to your zombie, you can now drag and drop your created asset directly into the inspector. So in this case, I can drag the enemy scriptable object that we made with right-click create scriptable objects enemy right into here so we can use it. And now you can see that when we run around, the zombie will chase the player until it's at a certain range of the player, which we can go to the project and click the scriptable object, zombie attack, and you see that the attack range is 5. Now if we change it to 1, you'll see that now the zombie gets closer to the player before attacking. And you see that when we stop pressing play here, the value is kept in the scriptable object, which is awesome. So you can easily use this to do any kind of other system, such as player stats, health, power-up stats, keeping a list of audio references, a list of objects, making an inventory system, or creating a save system. And it's great because this is persistent, so the data will remain the same regardless of whatever scene you're in, so it's scene independent. It allows you greater flexibility because you can easily drag and drop different scriptable objects in to test different parameters or values. So you can isolate testing different features more easily because you'll have reduced dependencies on different scripts, which I'll actually explain a little bit more of in a minute, and it's not bound to play mode. So I do want to mention that there are some functions that you can call within scriptable objects. The functions are awake, onEnable, onDisable, onDestroy, and onValidate. Now the execution of these is a little different than mono behaviors since this does not exist within the scene space. And the documentation on this isn't super easy to understand. Fortunately, I found this great forum on Unity by GetBrinkst explaining the different callbacks and when they are executed. So the awake function is mostly called when a scriptable object is created. In this case, it could be either in the editor or at runtime, which you can create scriptable objects at runtime. And I'll actually show you how to do that. It's also called when the scriptable object is selected when you click on it in the editor, although I'm not sure why. And GetBrinkst also seems to be confused on this. OnEnable is called when the scriptable object is loaded. So this is called after awake. It's called if the current scene reloads and a scriptable object is being used. And it's called if we enter play mode and the scene that loads also references a scriptable object. OnDisable is called when the scriptable object goes out of scope or is unloaded. So if a scene is loaded and there are no mono behaviors referencing the scriptable object, then OnDisable is called. If the current scene reloads and is currently referencing a scriptable object, OnDisable is called. It's also called in play mode when you enter a scene that has a scriptable object. So OnDisable is actually called first before OnEnable is called, which is interesting. And OnDestroy is called when the script is destroyed. So since this is a project level asset, this can either be that you destroy it through your script in code, if you delete it from the assets folder manually, or if you created a new scriptable object at runtime and you either destroyed it, quit the application, or exited play mode. And you can read through the rest of this forum if you're interested on more of the intricacies of the execution orders. It's quite complicated and it seems like the documentation doesn't clearly explain the functions well and when they're executed. So just to show you an example, I've put the debug.logs in these functions, and this scene has our zombie, which this script references our enemy scriptable object that has these debug.logs. So if we click play, you'll see that OnDisable is called first, OnValidate is called, and OnEnable is later called. And I forgot to mention that OnValidate is basically just called when a script is loaded or the value of the script changes in the inspector, which this can be good for debugging. Be careful if you use these functions because the execution orders can get a little messy. Make sure to print out the execution orders because if you're trying to reset something, you see awake was not called here. It's called when a scriptable object is created. But you see if we create a new scriptable object, right click create scriptable object enemy, press enter, you can see that in the console awake and OnEnable is called. So just keep that in mind. And now I'm going to show you how to instantiate a scriptable object through script. So I've already written a script just to show you how it works. This script is called instantiate scriptable object, and this is just a normal mono behavior. So all you need is to get a reference to your scriptable object, and this is the instance we're going to create. And then you can call this method scriptable object.create instance. And then you pass in the type of the instance that you want to create. In this case, we want to make an instance of type enemy scriptable object, and you have to cast it using type of, so we can get the type and pass it into this function. And then all I'm doing here is equaling it to test, which you actually have to cast it. This is a cast, meaning we're converting whatever type this is returning. So this is returning a scriptable object, and we're casting it to an enemy scriptable object so that we can easily reference it in our script and its values. And then we can use it as normal. We can do debug.log test enemy attack type.attack damage. You can access your properties as so. And then if you want to destroy the scriptable object, there's a function you can call called scriptable object.destroy. You pass in the scriptable object that you made, and then this is just how many seconds you want to wait until it is destroyed, which is a float. So just to show you how this works, I'm going to create an empty game object and attach this script here. And then if we press play, you'll see that first onDisable is called twice, then onValidate, then onEnable, then onValidate again, then onEnable again, then awake, then onEnable. And this null reference exception is just because I actually didn't pass in an enemy attack type to the scriptable object. But besides the point, after that, onDisable is called, and then onDestroy, and onDisable is actually called again after that. So you see there's lots of stuff going on here, so just be careful on the script execution order. Additionally, I'm not going to cover it in this video, I'm going to cover it in another video. There's another use for scriptable objects called event-based messaging, and it's where the scriptable object kind of acts as a middleman between two different scripts or components. So we can decouple the code, which basically means to separate or to remove dependency onto components. And when you remove dependency, it makes your life easier, makes it easier to test, more flexible, and easier to debug. So that's not going to be this video because that's a separate topic, but it is a great way to architect your game to be flexible and easy to change for both the coders and designers. And another thing I want to mention is to make sure you don't accidentally destroy your original scriptable object through code, because you only have one instance of it in your project. So if you destroy the original one, then you'd lose that scriptable object with your values. And finally, another usage is replacing enums. So if you're not familiar, an enum is just a collection of different names, and each name corresponds to its own identifier. So for example, this has an ID of 0, 1, 2, 3. And usually we use this when we want to have a list of IDs that we want to give something, or a list of actions or states that a game object performs. So this is actually used pretty commonly in state machines. For example, the player can be in a walking state, running state, idle state, and each of those would be a separate entry within an enum. Just as here, we have an attack type and we have different kinds of attacks that we can reference easily. Now the issue with this is that since each of these corresponds to an ID, what if you want to delete one, but your code references an ID of 1? Well, now since you deleted the original 1, which was a jab, now the new entry will be test, which has an ID of 1. And so what ends up happening is that to sidestep this problem, developers will just put none instead of actually deleting the attack type to avoid having to change IDs everywhere. And also for designers, this isn't really extendable because designers have to go into the code. They have to add an extra enum if they want another attack type, because the designers will probably want to be adding attack types or variables in. So they want to add dodge, and in doing so, they might mess up some code somewhere because the IDs don't match. So to avoid this, you can just use scriptable objects. Similar to this enemy attack type here, you have your attack damage, range, and sound. And let's say you wanted to add another kind of attack, you can just make a new scriptable object of type enemy attack, and you can just name it anything you want. Goblin attack swing. You can easily plop in your values here, and then you can just drag and drop it into whatever game object needs the attack instead of using enums. So that's just a side mention on another usage. So yeah, I hope you enjoyed this video and you found a lot of this useful. And thank you once again to Machinations for sponsoring this video. If interested, the link is in the description. So if you did enjoy this video, make sure to like and subscribe and hit that bell notification icon, as it helps me out a lot and you can get notified on all the new releases. So with that, I'd like to thank my patrons who help make these videos possible. So thank you so much for all of your support. If you're interested, the link is in the description. I offer source code, early access to videos, exclusive tutorials, exclusive Discord channel, and insights onto what I'm working on. So with that, I'd like to thank my new patrons: In the supporter tier, we have Thank You So Much. In the enthusiastic tier, we have Jin Sang Kim, ASM, Rafael, Follow Tomorrow, LTD M Games, Jack, Chung Wang Woo, Feely, Stargate Media, Marco, Horror Dev Brett, Kolja, James, Fane, Matthew, Mike, AJ Max, and Luam. Thank you so much for all of your support. It is really appreciated. It helps me make these videos possible. Once again, link is in the description. And if you haven't joined our Discord channel, be sure to do so. You can chat, post memes, or ask for help. So thank you again for watching, everyone, and I'll see you next time.